Alright, so this is how to do the AP Calc AB free response question number 6. Consider the curve given by the equation y cubed minus xy equals 2. It can be shown that d of y over d of x equals y over 3y squared minus x. Part A. Write an equation for the line tangent to the curve at the point (1, 1). So first let's divide this into 3 sections, A, B, and C. Okay, so write an equation for the line tangent to the curve at the point (1, 1). (1) equals x, 1 equals y. So first, to get the equation for the curve, we have to get the slope of the curve, and the slope of the line tangent to the curve at any point is given by d of y over d of x equals y over 3y squared minus x. Then we just plug these into here to get the slope. So y is 1, so 1 over 3 times 1 squared minus (1) equals 1 over 3 plus 1 equals 1/4. 1/4 is the slope. From there, we just used standard form. M times x minus x1 equals y minus 1, y1, to write the equation for the curve. Here's where y1 is equal to, or x1 and y1 are equal to the coordinates of a point on the curve, and m is equal to 1/4. Well, m is equal to the slope, which is equal to 1/4. So we just substitute in 1/4 as m, which is the slope, times x minus negative, then here the x coordinate is (1), so minus (1) plus 1 equals y minus 1, because y is 1. So here's the equation for the line. That's part A. Part B. Find the coordinates of all points on the curve at which the line tangent to the curve at that point is vertical. So, for a line to be vertical, the slope has to be equal to undefined. And the slope at any point, the slope of the line tangent to the curve at any point on the curve, is given by dy over d of x equals y over 3y squared minus x. So this has to be equal to undefined. And as we know in fractions, fractions are undefined if their denominators are 0. And here the denominator has to be equal to 0. So 3y squared minus x equals 0, which can be rewritten as 3y squared equals x. Now, we also know that y cubed minus xy equals 2, because that's the equation for the curve. And because this has an infinite amount of different solutions, we need to substitute this into something else. We need to substitute this into the equation for the curve. So, we substituted in y cubed minus 3y squared y equals 2. Then y cubed minus y 3y cubed. Sorry, that's not written very well. Y cubed minus 3y cubed equals 2. Those are equal. Just working through the algebra here. Y cubed times 1 minus 3 equals 2. 1 minus 3 is obviously equal to (2). Divide each side by (2) over (2). Y cubed equals (1). Y equals the cube root of (1), which is 1. So y equals 1. That's 3 right there. Alright, so y equals 1. No, sorry, (1). Because, again, the cube root of (1) is (1). So now we know y equals (1). So we just put that into this equation. So 3 times (1) squared equals x, which 3 times 1, 3 equals x. So we know y equals (1), 3 equals x, so the coordinates must be 3, (1). There we go, there are the coordinates. That's problem for part B. Now, part C. Evaluate d squared y over dx squared at the point on the curve where x is equal to (1) and y is equal to 1. So, this is the same point that we were evaluating the line for. We were evaluating the slope, the equation for the line at that point on the curve over here. So d squared y over dx squared. First, y equals 1, x equals -1. Let's just write that out. So this is the second derivative. To get the second derivative, we just take the derivative of the first derivative, and the first derivative is this. Yeah, what was it? There. Y over 3y squared minus x. So we take the derivative of that just using a quotient rule. So top is y, and we have to use implicit differentiation here. Bottom is d of y over d of x. Bottom is 3y squared minus x. Derivative of bottom is 6y d of y over d of x minus 1. So, now we just use quotient rule, low, which is 3, I did write that down, 3y squared minus x, times derivative of high, which is d of y d of x, d of y over d of x. So low d high, minus high d low, so y high times derivative of the bottom. 6y dy over dx minus 1. All over the bottom squared, 3y squared minus x squared. So, we also, just in addition to x and y, we do know the slope of the line at that point. Because, again, over here, we solved for the slope of the line at the points -1, 1, which is a fourth. So we also know that d of y over d of x equals 1/4. So now we just substitute those in. Let's see, 3 times 1 squared minus -1 times 1/4 minus 1 times 6 times 1 times 1/4 minus 1 all over the 3 times 1 squared minus -1 squared. So let's just bring that down to here. Simplify that, that's 3 plus 1, 4. 4 times 1/4 minus 1. We can just cancel out the 1 here because obviously 1 times anything is just that number. So 6 times 1/4 minus 1. So 6 over 4 minus 4 over 4. All over 5, because yeah, that's 3 plus 1, 4 squared. So, because that's 3 plus 1, 4, 4 squared. So that equals 1 minus 1/2, because 2/4 is 1/2, over 4 squared, equal to, you see that? You can see that. 0. I'm just going to write, yeah, which is 0.5 over 4 squared. It's easier to write in decimal notation. Then multiply top and bottom by 2. So then 4 squared is 16, so that's equal to 1 over 32, because 16 times 2. So that is the final answer. The second derivative of dy, how is this written? Yeah, here, d squared y over dx squared when x equals -1 and y equals 1. So here, the answer to this is 1 over 32. that is how you do the AP Calc AB free response question number 6.